Hello everybody. Okay, now let's try something first. Reset the microcontroller. Okay, I insert the SD card. Okay, okay, that's alright. You can hear that the replay is clear, not much noise, and it sounds quite alright. Okay, and this is the result that we're going to get today in this video. Okay, so let's see how to make it. Okay, this is the idea behind that I get an array called buffer, and this is 256 byte size. I use a variable called read index to retrieve data from the array and perform the playback. I have to set another variable called write index that indicate where the data from the SD card is being filled into the buffer. Let's imagine that when Ri is somewhere between 0 and 255, say 128 or 800 or something, and the Wi is at the end 255. That just a moment later, then it's stacked to read in another block of 256 bytes. Then the Wi will rewind to 0 and somewhere, and the Ri would advance for some value. Okay, so it will look like this, and still sometime later both Wi and Ri would advance forward. Then after the read index reach 255, it will become 0 again, and the Wi still advancing. Okay, and then sometime later it will become something like this. Okay, but I also notice that the Wi would run forward faster than the Ri runs forward, so it will corrupt data and make noisy. So here I'm going to make some checking. When the write index approach the Ri to some extent, I will slow down the SPI clock rate so that Wi will never catch up the Ri. Okay, this is what the idea that I use. Okay. Okay, now let's begin to handle the program. Okay, make a new folder called 8-bit part 2. Okay, copy files from 8-bit part 1 to part 2. Okay, I already make a new folder here. Okay, this is the 8-bit part 2. Okay, from 8-bit part 1, so I will copy. Okay, then I delete those 3 files. Okay. Okay, activate the AVR Stidio. Okay. Okay. Okay, has source files, add the files. Okay, and then set the crystal frequency 16 megahertz. Okay, okay, that's all right. Yes, okay. There is one difficulties. Yes, I would like to set a value here for the WI, but this value has to be accessed in main.c here. It also has to be accessed in the AVR mmcp.c. Okay, but actually I'm not so good in programming, so I fall into trouble here. But then I just find it. The variable buffer can be accessed in the main.c. It also can be accessed in the AVR mmcp.c. Yep, the value here. Okay, the variable here. So I just set WI in a way that that the buffer is set here. So I set a variable, okay, like the buffer here, so it can be accessed in both files here. Okay, so let's see how to do it. Okay, okay, in the pff.h. Okay, pf3. Okay, pf3 is here. Okay, I just make a change like this. Okay, and in the main. Okay, add NWI to FA. Okay, NWI. Okay. Okay. Okay, it's here. Okay, now to the pff. Okay, pff.c. Okay, so that is to the pff. Yep, here. Okay, then in the AVR Stidio, you see it. And that is okay. and in the dsect.h. Okay. Okay, now let's try to compile it. Okay. Yep. That's correct. Okay. Document 5 with double curse. Okay, forget it. So here I add a dummy variable into PFF. Okay. 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 I just put it here. Okay, let's see what is the result. No, okay, forget it. Okay, I just keep trying to replace all this function to correct this. Okay. No, not change here. Nothing to be changed here. Okay. Okay. Let's compile it again. That's 1, 2, 3, 4. Okay, I think I got a mistake here, so I have to check out something. Okay, that's the PFF. Okay. PFF. Okay. If 512. Okay. Okay. Two, three, 4. Plus 1, 0, 1. Okay. Plus 1, 0. There. Yeah. That's a good one here. Okay. That's alright. Okay. Okay. I need a comma here. PF3, okay. Okay. I have to add this one also, okay. Okay, it sounds good. And still I have to make some other change. Yeah, it's here. In the main.c, I have to change this, okay. I have to add this one here, okay. In the main.c. Okay, and naturally, I don't have to change the SPSO. Okay. Okay, that's all I need, okay? So, I will build it, okay, and I try to upload the program to the, yep, it too, okay, that's good enough, okay. Okay, go to file. Okay. Now I insert the SD card. Okay, we got rest. Okay, it sounds good.
Together to a dreamy melody.
Okay, good. The result is quite good. The playback is clear. And now I would like to test some other things else. Then I got a wave file for 22 kHz and mono 8-bit. That means it needs a very slow reading rate from the SD card. Okay, let's see if we can play correctly. This is 22 kHz. Okay, it sounds good. Okay. Then I play another one. This is 22 kHz stereo 16-bit.
I'll never let you see.
Okay, I think this is good enough. Okay, and thank you for watching. Okay, bye.